Okay, let's talk about this problem, okay? It is a resultant force problem, okay? So F1 and F2 is given, like the magnitude of F1 is 10 pound and magnitude of F2 is 12 pound. And the reference angle from the bottom line is 45 degree and 30 degree, okay? So even is the problem is given like this way, but we have to write these guys as the component 4, okay? Here we go. So let's start from F1. Like in the problem, the magnitude is 10 pound and it will be 10 times cosine with reference angle, which is 45, and 10 times sine 45. Is it okay? But wait a minute. If you do like this way, it is wrong. Okay? So we are talking about engineering calculus and it is vector. Okay? So depend on direction that we have to decide the sign. Okay? So basically look at this vector. It is pointing this way, right? Your x component is pointing negative side and y component is pointing positive side, which means whenever you use a reference angle for your cosine and sine value, those are all positive number, okay? So these are positive, okay? So since we didn't use the a real angle but reference angle, you have to decide the sign of your x component by yourself, okay? Look at that, pointing negative side, which means your x component must be negative. Don't forget this, okay? If you miss this one, your answer will be wrong, okay? So this one is equal to negative 10 times, you have to remember this special angle trigonometric function, okay? 10 times this guy, which is negative 5, 2, and 5 square root of 2. That is your F1 vector, right? Negative x component and positive y component, okay? What about F2? Positive x component and positive y component, okay? So you don't have to worry about the sign, okay? Here we go. F2 is equal to, the magnitude is given by 12, positive, and cosine with reference angle, and 12 times sine 30, okay? Unfortunately, you have to memorize this guy, okay? Cosine 30 is square root 3 over 2, and sine 30 is just 1/2, okay? So that is simply 6, 3, and 6. We found F1 and F2 as the component 4, okay? Then what about resultant force? Here we go. Resultant force can be calculated by just simply add up two vector which is applying to the that point, okay? So that is equal to negative 5 square root of 2 plus 6 square root of 3 comma y component 5 2 plus 6. That's it. This is resultant force, okay? So it's to question ask you find the magnitude, okay? Magnitude is just the length of this vector, okay? Here we go. So it's simply the length of resultant force vector that can be calculated by square root of x component and square plus y component square. That's it, okay? But unfortunately, there's no way to calculate this one by hand, okay? We can simplify a little bit, but we are not going to do, okay? So now, let's talk one more thing, okay? Which is direction. So for this problem, we're going to try to find the, the angle from the positive x-axis, okay? So look at this one. Your x component is positive value and y component is also positive. So your vector, resultant vector is pointing this way. Is okay? So whenever you have to find angle, this angle, then you have to use the right triangle like this way. Then we're going to use the tangent, okay? So your opposite side, that's exactly your y component of your f, which is 5 square root of 2 plus 6, right? What about adjacent? That is x component, right? Negative 5, 2 plus 6, 3, okay? So we know like opposite and adjacent, right? Then we can write this one as tangent. So tangent theta is equal to opposite over adjacent. Okay, so finally your answer. Angle theta from the positive x-axis is tangent inverse or arctangent of right-hand side. That's it.